identities that are going to be used, not necessarily to solve them, but to substitute. Okay? So our first example today is something you guys have done at least 10 times. What's the answer? Sine of x equals a half. What's the answer? Do we want them in degrees? Not necessarily, because we're in not a triangle, so therefore we want radians. Where does sine equal a half? Pi 6. That is a great answer. Does everybody agree with me? Anywhere else? Is that the only place? Where else is it? 5 pi 6. Anywhere else? Yes. Think about, because that's just, once again, guys, right? That's just one cycle that we found these two answers here, right? That's only one cycle. Does sine stop after one cycle? No, it continues on. And it goes on this way and it goes on this way, doesn't it? So how many answers are there? Infinite. There's an infinite amount of answers. Would you guys agree? Okay, so how do I write all those answers? Well, ladies and gentlemen, how do I get from this point to this point? I add how much? 2 pi. So I add 2 pi. But can I do 2 pi over and over and over and over again? Could I also subtract 2 pi over and over and over again? So what we do here is we write 2 pi n, where I also have to write n belongs to the integers. That looks a little different. That Z-looking shape, by the way, let me show you how I did it again. Just like a normal Z that way, then come back up and come over. That symbol represents integers. What is an integer? Does anybody know? Yeah. Okay. So negative and positive numbers. So negative a half is an integer. Our counting numbers. Okay, it's our counting numbers, which we call our natural numbers, right? And then our whole numbers are counting numbers plus 0. Integers are our whole numbers and they're opposite. So like negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, and so on, both directions. So it can't be a fraction. Well, I guess those are fractions. It can't be a decimal. It has to be a number and its opposite. Does that make sense? So when I go ahead and put n, give me any integer. Anybody give me anything? 2. What's 2 times 2 pi? So therefore, it's taking these answers and adding 4 pi to it. Or if I say negative 2, that would be taking those answers and subtracting 4 pi from it. Does that make sense? So this is giving me every solution. Okay? Does everybody understand this part here? This thing? This right here, it's like an E, but it's in math, we call that belongs. N belongs to the integers. It looks like a 3 backwards. Okay? Does everybody understand notation? Is there any questions on notation? Anybody want to buy some Girl Scout cookies? I got to sell them all by the freaking end of this week. I do. You want to buy a case? It's $50. We'll shake it down, half a case, $25. Shake it down one more. One box is $4. Anybody else want to buy some cookies? I got those. I got one Samoa because nobody came back in. And I got some Do-si-dos. Anybody like Nutter Butters? They're like Nutter Butters. Oh, and Tagalongs. Oh, I love a Tagalong. There's delicious. They're like, you guys weren't around back in the day when we had peanut butter Twix. They were delicious. Huh? Yeah, you don't see them as often. But when you freeze those ones, ooh, even better. Okay, how was that example? Pretty easy, right? You guys ready for another one? Here we go. It's really hard. We're going to have struggles here. Oh my goodness. Woo! It's a hard one. Anybody know what to do? You don't know what to do. We add root 3 and divide by. It's not a hard one. I was kind of being facetious. Is that the right word there, guys? Facetious? Yes! I used a big word. Mr. Harmston, how are you? You want some Girl Scout cookies, don't you? You're contemplating. I see it in your eyes. You could get a sleeve for $2. There's a sleeve of Thin Mints. I might. I have to sell all these things by this weekend, so if not, it's coming out of my money. So I might start doing. I only have what's in there. Tell me, he'll count boxes. Hold on, we're gonna make him. Hey, Burdette, get in there. Count some boxes. Giddy up, horsey. Okay. Oh, anybody want to share a box of tag-alongs? Right there, you will? $2. I take Venmo. Do it. Roberts BJ. Okay, where does cosine equal root 3 over 2? These are going to be the same answer because I was stupid. But not really. They're not the same answer, actually. Pi 6 and... There we go. But once again, how do I get back to those? Add 2 pi n. And what is n again? N belongs to the integers. Do you have to write this? That's what I got last time. Yes, because if not, what could n be? Anything. It could be a half. And what's 2 pi times a half? Pi. And if I take pi 6 and add pi, that's 7 pi 6, and that's negative root 3 over 2. That's not the same, is it? 32 boxes, people. That's $128 I need. Okay, bring it over. There's my change. We're getting there. Go back in the back and grab your Thin Mints. Come on up. Come on up. Ben Stoner did pay me $2. He did his share. Where's yours, Buckwheat? That's right, you are. Okay. Yep, you two go get a tag-along box. Yes! We're getting some monies. What am I doing now? Oh, that was pretty easy, huh? You guys ready for another one? Yeah, baby! Oh, yeah. Does that scare you guys a little bit? Makes you a little nervous? I really kind of don't want to do that. Just because then a lot of times kids, you don't understand. When did I tell you I used to have my vending machine business here at school? That I'd make 50 bucks a day selling crap? Yeah. I used to sell 8 12-packs roughly a day. I'd have, yeah, in my, not when I was at Lone Peak. And I'd sell potato chips. I'd sell cookies, like grandma cookies. No, not necessarily, but what some people say, hey, you're taking money from kids. So most of the time I make people put the cash on the table and then I take it like such. Did you get yours? Did you open up a box? Okay, where's your sleeve? I gotta see it. You're not even pounding it right now? You have great, what is that called? Self-restraint. Okay, here we go. So where does tangent squared equal a third? Do you guys know where tangent equals a third? Or tangent squared? Nope, so how do we got to get rid of the squared? Square root. Now, Earlier today, one of my students said, Mr. Roberts, this looks like I should verify. And I said, no, because the difference is, what does verifying say? Verify. What would this say? Solve. So on your test, I've had some people try to verify when they should have solved. But look at your instructions, okay? There is a difference in instructions. Yes, sir. As a sleeve or a whole thing? Okay, that's $4. I'm selling like I'm wheeling and dealing today, guys. Well, then I need more than 2 more. Or has he got money? Wow, hold on, Jaden. I got to see. I got double. Yep, double Jaden. Good. In there. We're getting down to 30 boxes and a half. Thank you for supporting young girls. They get, my daughters, it pays for their camps. It's like $500. Ooh, I don't know that one. I don't know. So I'll tell you where the money goes, because I was the cookie mom. They call them cookie moms, but I was the dad that did it, because nobody wanted it. And I'm like, I'll take it on. I was a cookie mom one time. So there's $4 a box. $1 of it goes to Girl Scouts, like Girl Scouts. $1 of it goes to making it. It only costs $1 to make it. So there's $2. $1 of it, I can't remember where that one. I can't remember. And then 50 cents goes to your troop, and 50 cents goes to the girl. So now she doesn't get cash out of it. She gets Girl Scout dollars, which they can use for Girl Scout items like the camps, or like there's some things that they buy and things like that. Where does tangent equal root 3 over 3? That's something that we should know. That's where the coordinate is root 3 over 2, comma, a half. Man, I'm using the same damn ones over and over again, am I not? What's the answer? Pi 6 and 7 pi 6. Now notice, I could write that and say plus 2 pi n, but I'm not going to. I'll show you what I would really write. Hold on, give me a second. So what I truly would write, though, is just this answer. Now, once again, n needs to belong to the integers. Okay? It was a comma, but I don't need a comma. How's that? Is that better? Are those the same answer? Yes or no? Why? What's the difference in between here? Just pi. And that makes sense because one's in quadrant 1 and one's in quadrant 3, huh? Isn't that a difference of pi? A half a circle? So therefore, I should write the more simplified one. Now, let me hear you also talk about this. Can anybody tell me what was the period of tangent? Let's go back here. What was the period of cosine and sine? Makes sense, doesn't it? Because it takes a period to get back to where I was, right? Correct? You guys with me? You understanding how it's working? Hey, by the way, did you get your grade change? Okay. All right. Now, all right, this is a good one. I think that's not squared. Oh, I hear change a rumbling. My wife always tells me, she's like, you can't hear me when I'm 3 feet away, but yet you can hear the slightest sound. I'm like, it's called teacher ears. You figure out stuff when you want to. All right. Any ideas? If I divide, I lose answers. Because when I divide by a variable, it loses those answers. Does that make sense? So you never, ever, ever, when you have variables, want to divide over a variable to get rid of something. Subtract. Good, I like that answer. Oops. I did this last class too. Okay. Anyone else? Factor. Look at you, Miss Nuddle Embry. Yeah. When I factor that out, I'm left with a cosine squared minus 2 equals 0, correct? Now I have two things timesing together to equal 0. How do things equal 0 when each of those equals 0, right? This is very similar to solving a quadratic formula, isn't it? Or just a quadratic equation type of a situation. Ryan, you good? Okay, I just saw you squinting. You need some glasses? You'd have to get special goggles for swimming. Maybe that's why you struggle a little bit, you know, every now. I'm not saying I'll shut up. I never said that you struggled. You swim, you'd kick my trash in a race, and I'll just put my foot in my mouth. Anyway, maybe that black line below got a little wobbly. Yeah, that was definitely a foot in my mouth. I think you're. I'll shut up. I think you're. Oh yeah, just say that. It was the Fords that taught swimming, not your family, right? Yeah. Sometimes I get your family and the Ford's family a little mixed up. Because you're both swimmers. Aren't you a swimmer? I thought your older sister swam. No. What was your older sister's name? Which one did she have? I remember the one. She's really quirky. She was fun. Yeah. Kennedy. No, Danny. Danny was a little quirky. Isn't she? I thought so. I'll shut up. I really liked all of them. They were all nice. I swear it was Danny. Did I have Kennedy? I think I had Kennedy. My daughter's name's Kennedy. I'll shut up. Onward. So where does cotangent equal 0? Once again, what's cotangent? X over y, or you could think cosine over sine. And so basically, if you're thinking as cosine over sine, we're thinking of where cosine is 0, right? Where is cosine 0, or your x value being 0? Pi halves and 3 pi halves. Good. Pi halves and 3 pi halves. But what are they separated by? Pi. So this time I'm just going to go pi halves plus pi n. Now, if you wrote pi halves, 3 pi halves plus 2 pi n, are you wrong? No. Could you have simplified it more? Yes. Does that make sense? Okay. And then here we get cosine of f. I keep losing my variables. Like Toodles. He lost his marbles. I watched Hook this weekend. It was great though. Looky, looky, I got Hooky. Rufio. You guys don't even watch that stuff, do you? Have you ever watched Hook? It's a great show. Movie. What do we call movies? Flick? I don't know. Where does cosine equal root 2? It was, but I square rooted him. Hence why the square root. No, that's square root of 2 over 2. Is square root of 2 larger than 1? So can cosine ever equal something larger than 1? So is there any values in here that's going to make that work to equal 0? No. So there's no solutions out of that guy. So who's our solution? Just this guy. Oh, by the way, this is cotangent, not cosine. You sinker thinker. It should have a period of pi, huh? I was thinking it was cosine, but isn't that should have a period of pi because it's cotangent? Whew! The whiff scared me. Hello. I'm hoping not because they're all gone. Did you throw anything away because they were all wet? I'll check the back. All right, I will check back there. Thank you. Bye. Okay, onward. Onward. You gonna go? You'll have a good time. Planning the schedule? AP Calc? Yeah. Yeah. You ready to rock? Okay, here we go. We're having a little bit of issues here this time. Can I get factor out like what I did last time? Like factor out that cotangent? No, I got sine squareds and a cosine. That's a slight dilemma. I wonder what I could do. Into what? I like what you said, Miss Stoddard. If you guys did not hear her, she said, how about we switch sine squared into 1 minus cosine squared? Why is that a good idea? Now everything's in terms of cosine. So it's kind of putting them all in the same type term. Does everybody understand that? Have you ever learned this stuff before? You guys did? So that's kind of, all right. I'm just kind of seeing. So you are learning. That's my always curious thing, is to make sure that sounded horrible, that you lovely foreign exchange students actually learn. I had a student last year. You were bored. That's what I had last year. I had a girl that was in secondary too, and she'd watch videos the whole day, and then she'd come ask me questions about what her friends were doing back home in Spain, España. And then I'm like, let's just move you to this class. And it actually made her think and work, and yeah, it was a good thing. So I just wondered, doesn't that look a lot nicer? Okay, so let's go ahead, and I'm going to get everything over. That, by the way, makes -1, getting him over. So I get 0 equals 2 cosine. Now, why did I do this? I like to have my cosine squared usually be positive. That's mainly my reasoning. Could I have done it the other way? Sure, I could have. If anybody has questions on how I got there, just let me know. Yes, ma'am. Well, right here, what's 2 minus 3? -1, but I got him to the other side. So what does that make us now? Does that make sense? Hey, there's some basketball stuff coming up. You see that thing? They have some open gyms. I don't know. I saw it on the internet. I didn't look at the date, but I know they have some like training too. Just give you a heads up to make sure you're on the ball. Doesn't this look like 2x squared minus 3x plus 1? So we could do what? Factor like the tractors we are. I like tractors. That was my first driving thing, was a tractor. Anybody else drive a tractor? Man, that's just sad. Good time driving a tractor. I think I might be in some slight dilemmas. Okay. So basically this is saying where cosine of x equals who? Add the 1, divide by 2, 1/2. And this one's saying where cosine equals 1. Do we all understand that? If you don't, here's why. I just didn't show the work, but remember when you're factoring, this binomial has to equal 0, right? And this binomial equals 0. Yes, ma'am. Let's check. 2 cosine times cosine is 2 cosine squared. 2 cosine times -1 is 2 cosine of x. Minus cosine of x, that's -3. So far, and then -1 times -1 is, all right, are we good there? Does everybody understand how I went from here to here, though? Because basically I was setting each of those equal to 0. Remember, guys, so far your grades are really straightforward, right? Because there's not a big test and it's just been assignments. So make sure we're staying on top of those so we can work our way through the whole quarter, not just at the last. Where does cosine equal 1/2? No, pi thirds and 5 pi thirds plus how much? 2 pi n. Where does cosine equal 1? Remember, that's your x value equaling 1. Not pi halves. 0, 2 pi, so forth, right? So that's 0 plus 2 pi n, but what's 0 plus anything? Just the anything. So could I just write 2 pi n there as well? Where once again, n belongs to who? The integers. Excuse you. Any questions there? Borsk, you doing good? Okay. How's the wordscape going today? Yeah, finding all of them? Let's see. Anybody have an idea here? Nobody? Subtract sine over? I could. I don't want to do that yet. I could, but it'd just make it a little nastier. Once again, what's our situation and what's wrong with this one? I have two variables again, right? Kind of a way. I have a cosine and I have a sine. I don't want to have two unless I can factor things out. If I get him over, can I really factor stuff out? No. Anybody have an idea? Ooh, who said that? Ryan! Good job, Ryan. We can. Now notice the difference here once again. I'm going to come back to you, Abby. Is this is solving, not verifying. If I was verifying, I could not do this step. Okay, make sense? I'd probably times by my conjugate. Top and bottom. I don't know what that would do, but because once again, here we go. So when I square this, I get cosine squared of x plus 2 cosine of x plus 1 equals sine squared. Now, who do I want to change? Do I want to change the sine or the cosine? The sine, because could I change a cosine squared to sine squared? Is that okay? Could I change that regular cosine, though? That's our issue. So therefore, that's why sine is going to be changed to 1 minus cosine squared. Is everybody there with me? Yes, no, maybe so? Okay, and then I'm going to get everything over to one side. So when I subtract the one that's gone, but when I add that over, I get 2 cosine squareds of x plus 2 cosine of x equaling 0. Sid the squid, what am I doing? Factoring, huh? 5831. Yeah, I do. That's why you should not tell me things. Okay, so we're going to factor. My daughter just found out our passwords to all our Kindles. Little scallywag. She found out one, because all our kids are pretty young, so it was kind of silly. We did, so like technically iPad is mine, so my wife put my birthday on it. Her Kindle's hers, so she used her birthday. No, but they never knew, and we always made them like to undo it. They had to face the other direction, and so they never found out. And she's like, "Once I found yours out, I got everybody's." So I'm like, makes sense. Okay, so basically this is saying where does 2 cosine of x equal 0? And where does cosine of x equal -1, correct? Yeah. Right here? Is that what you're talking about? But because they both have it, so I factored it out. This one up here? Okay. So what I did here, sorry about that, is I added cosine squared over. So when I added him over, gone, right? So what I do to one side, I do it to the other. You with me there, Ash? So therefore cosine squared plus cosine squared is 2 cosine squared, and then I already had 2 cosine x there, and I subtract the 1 here, subtract the 1 here. Why did I already have that? Because that was, oh, so you're asking where this guy came from. Okay, I'm with you now. When I distribute him, I can't just distribute in, right? Remember, I got to go cosine of x plus 1 times cosine of x plus 1. Does that make sense? So this is basically saying where does cosine equal 0? Equals 0 at x equals pi halves and 3 pi halves plus 2 pi n, but I could just write that plus pi n, can't I? Is everybody there with me? Now notice that's not its period, but that's where it happens. Between pi halves and 3 pi halves, it's just adding pi, correct? Half a circle. Where does cosine x equal -1? Pi, right? So I'd have to write x equals pi plus 2 pi n. Once again, where n belongs to the integers. Pretty easy day today, right? That's nothing too hard. There's only one thing I want to talk about more, is something like this. Give me 1 second. All right. So instead of just having x this time, we have 3t or 3x, I could even say, right? There's nothing different there except that inside's 3. What did that 3 do to our graphs? Shrunk it. Didn't it shrink our period as well? So watch what happens here. Let's go ahead and solve just like we did. So I have cosine of 3t, but in the back of your head, look what's going to happen. So still, I say, where does cosine equal root 3 over 2? Pi 6 and 11 pi 6. Plus 2 pi n, right? But that's saying that we're using regular cosine. Are we using regular cosine? We're using 3 cosine of 3t. So guess what I have to do to all these numbers? Divide by 3, divide by 3, divide by 3, divide by 3. I have to even do the period, and that makes sense because our period is no longer 2 pi, it's 2 pi thirds, isn't it? Hence it hits it every 2 pi thirds. Does that make sense? Because the period changes, right? So I have t equals pi 18ths, comma, 11 pi 18ths, plus 2 pi thirds, n. Now, in your homework today, they might ask you not to find all the solutions, but just solutions between 0 to 2 pi. This is a solution for every solution out there, correct? What if they only want answers between 0 and 2 pi? What would I have to do? Say it louder, Carson, or if you're saying it. 2 pi thirds, right? So I have pi 18ths, that's an answer if I wanted between 0 and 2 pi. Okay, if I add 2 pi thirds to that, does everybody understand that is 12 pi 18ths? Okay, so 12 pi 18ths plus pi 18ths is 13 pi 18ths. 11 pi 18ths, because that's given. But if I add 2 pi thirds to that, which is 23 pi 18ths, correct? Could I add some more? I could get 25 pi 18ths, because I'm not to 2 pi yet, which is 36 pi 18ths, right? Is everybody with me on here, understanding how I'm getting these? Because once again, I got to divide everything by 3. Not just the numbers, I got to divide everything by 3. And notice that should make sense for the fact that my period's no longer 2 pi because it's shrunk. So therefore our period's now 2 pi thirds, hence why we're changing it every 2 pi thirds. So I have 25 pi 18ths, and then the last one should be 35 pi 18ths. Okay, all those answers are answers between 0 and 2 pi where it would make it work. Does that make sense to everybody how I got that? What did I just keep doing? Adding 2 pi thirds, right? Correct? Was that a hard day? For some reason, people struggle here. On the test that I've seen and I've given a lot of times, what do they think they forget to do? Divide by 3 to everything. Okay? So don't get stuck on that. If you need the homework again, it's right there.